everyone, thank you for attending my talk today. I will be discussing Greater Prairie-chicken habitat selection on Fort Riley Military Reservation, just a tidbit of my master's research. Greater Prairie-chickens are currently in decline. They are limited to mixed grass and tall grass prairies. Their populations have declined 75 to 80% from historic levels. And this is largely attributed to habitat loss and conversion of land, as well as land mismanagement. However, in Kansas, we currently have one of the largest remaining populations of Greater Prairie chickens. So we have about 79,000 birds left in the state, and most of which are centered around the Flint Hills ecoregion. The land in the Flint Hills isn't lucrative for cultivation because of the rocky soil, so this may be a saving grace for Greater Prairie chickens because they still have remaining grasslands. However, there are some contemporary ranching practices that pose issues for these birds. And these issues include things like intensive grazing, so overstocking, as well as annual burning, which doesn't leave a lot of habitat on the landscape for Greater Prairie chickens. However, there is an area within the Flint Hills that doesn't allow grazing, and this is the Fort Riley Military Reservation. Fort Riley also implements a burn mosaic management style, as seen here, which I will get to in a little bit. The question that I'd like to answer during this talk is, if Greater Prairie chickens aren't subject to the intensive burning and grazing found on many private lands in Kansas, what habitat types will they select? Getting into my study area a little bit, Fort Riley encompasses 41,000 hectares of land, 29,000 of which are used for wildlife management. Prescribed burns are implemented on the reservation at various frequencies, along with the occasional wildfire due to military activity. If you look at the bottom picture on the screen, you'll see this is Fort Riley outlined. However, Fort Riley is broken up into little squares that each have a different shade of gray. And this shade of gray corresponds to the frequency of burn. So the lighter the shade of gray, the more frequently that area is burned on Fort Riley. Some of my methods for this project, we captured Greater Prairie chickens on the reservation from early March to late April using walk-in traps. There were some times during the study where these chickens just did not want to cooperate. And as you see in this picture of the road, there are some traps set up on the road because these birds just would not want to lek in the grass. Instead, they lekt on the road. So we, by golly, pounded our rebar and traps into the road to catch them. We were pretty successful. So in 2019, we caught 22 females, and in 2020, we caught 16 females. Each female was outfitted with a GPS satellite transmitter, which allowed us to get locations of these birds during the breeding season. We also conducted vegetation surveys. We conducted them at nest locations, used locations by the birds, and at random locations across the landscape to get an idea of what was available to these chickens. At each survey, burn frequency was noted. So going back to my question, I was particularly interested in the habitat types that were selected during the lekking season, the nesting season, at used locations, and at nest locations. So giving you a little background to start off with, this was a study conducted out of Oklahoma State, and it describes the overall habitat selection of Greater Prairie chickens throughout the breeding season. So in the lekking season, birds chose these really short grass areas to lek in. However, during the nesting season, these birds selected for areas with denser vegetation with more structure to provide concealment for their nests. Getting into my results a little bit, starting off with the lekking season habitat selection, I looked up the probability of use of different fire frequencies on the landscape. So on this x-axis, you see the fire frequencies at a 16-year average. So as a reference, a fire frequency of 0.5 would mean that an area is burned every 8 out of 16 years or every other year. And a frequency greater than that means it's burned more often. So we see here that during the lekking season, these chickens selected for areas that were frequently burned in both 2019 and 2020. The same trend is seen during the nesting season. So these birds selected for high frequency burned areas. Getting into more of these spatial components, I conducted a hotspot analysis on GIS. So these hotspots or areas of frequent use are represented by these boxes in this map, and then the map is overlaid by different seasonality of burns. So which season of which year where area is burned. And we see between these two maps that locations are pretty similar on the landscape. So they're in similar areas. However, the burn seasonality between the two maps differs. So 2019 burns used areas that were burned in fall of 2017, so about a year and a half before the study took place. However, birds in 2020 selected for areas that were burned in fall of 2019, so like 6 months or less from when they were using that area during the breeding season. The same is true for the nesting season. We see similar locations in similar places on the landscape. However, that burn mosaic or burn frequency shifted between years. Getting into specific location uses, we see that for use locations, birds selected for areas that were burned every 1 to 2 years and selected against areas that were burned every 2 years or more. And the same is true for nest locations. These birds selected for areas that were burned every 1 to 2 years, so very frequently. And they selected against these areas with less frequent burns, which would provide more cover. So that was interesting. To provide you with some more context of where these locations were on the landscape, here's a map of 2019 nest and lek locations, and then 2020 nest and lek locations. Again, they're in similar places on the landscape between years. It's just that burn mosaic, so the time since burn shifted between years. And below, here are some tables that show the total number of nests that were located in each time interval of burn, the number of successful nests, and then the apparent survival rate between the 2019 and 2020 nests. So despite birds selecting for similar locations on the landscape to place their nests, the areas in which they placed their nests really determined their survival. So birds that placed their nests in areas that were burned 1 to 2 years only had a 9% survival estimate, whereas birds that placed their nest in locations burned every 2 to 4 years had a 21% survival estimate. So what does this mean? Overall, birds selected for habitats that were frequently burned. However, we did see a difference in yearly selection. So in 2019, they selected a little less strongly for these frequently burned areas. And some reasons why this could be is because there was a lot more precipitation in 2019. So maybe these birds were choosing to stay put to decrease their chances of being predated. Or maybe these variations in years were due to the variation in burn mosaic. So although the locations on the landscape were similar that the birds selected for, the time since burn differed quite a bit between years. The same is true for nest locations. So they were consistent on the landscape the locations were, but the changing burn mosaics between years led to differences in survival of nests. And overall, this means that birds seem to select for location on the landscape rather than time since burn. So they select for specific locations instead of like vegetation structure. And this may lead to differences in survival rates. So we saw that with nest locations, and this could be true for survival. So it's really crucial that we have the proper burn intervals to allow the greatest chance of survival for these birds. Because it'd be pretty sad to end up like this little guy, and we'd much rather see birds alive and well, and allow these birds to persist on the landscape. So burn intervals and burn regimes are really important to manage for, especially in Kansas, to keep these birds persisting into the future. And with that, I would like to thank quite a few people here. My technicians were great, my lab mates were great, as well as Alan Hynek, Sean Stratton, and Derek Moon out of Fort Riley, as they were the leaders on the Fort Riley side of projects and allowed me a lot of information and have been super helpful along the way. So thank you.